Welcome to the TELE 1022-24 Fall Telecommunications course. Um, as you know, every beginning of semester, we have to go through some of the logistics. We already had one lab, which kind of works in a bit of a funny way, because first we get the lab, first we get the lab, and then we get the theory. But we're going to make that thing sync. So here's our splash screen. Now I sent you the email about this lecture, but I'm just going to put that thing in the announcements. Just the first week I sent you an email, and I'm just going to put that in the announcements. So that should be fine. Lab kit, we already have gone through that. Somebody asked a question yesterday, because when you go to the bookstore and you can see the two different packagings, one package is sort of like a heavy stock box, like a brown little box, paper box, and the other one is in plastic Ziploc bag or something like that. They are both the same. They contain the same parts, exactly the same parts. It's just they're packaged a little bit different. So I would encourage you to, encourage, you gotta have those parts to be able to do the labs. Just make sure that everything that's on the list, that it's there. Those coils or inductors, they look like bigger resistors, like half-watt resistors, but they're actually coils. And I did this. You can organize it in whatever way you want. So yeah, I'm not going to spend much time on this. Okay, so now we got to go through some of the logistics of the course, and then, but I also promise you that you're going to get some content today. So you will leave with something. Let's see how this thing, how long it's going to take us to go through this content. I have set a landmark as far as the lecture notes. So we can finish this thing on certain spot. All right, so here is. Let me just bring it to the what? You're still there? I guess you're still there, right? Okay, good. All right, here we go. Here is our presentation. Telecommunications, it's just lab introduction, but it's pretty much the whole course introduction. So, welcome I said, my name is Professor Bach. I prefer to be called by my last name. And we will carry together the theory and the labs, which works. I like the way it works. One person doing theory and the labs, that's fine. Lecture times, Monday 2 to 3, and that's in person in room 2002, T2002. And on Thursday, which is today, 10 to 12 online. We got a little bit of a blending going on here, more than half online and some in person. Personally, I prefer in person. However, there is certain advantage to teaching online, at least part of the course, because that enables me to show some of the more details, and in all the comfort of my PC here, I can show you some circuits and multi-sim simulations and stuff like that. Otherwise, I wouldn't be able to do that in the classroom here. Lab, we already know it's Wednesday, so note taking in class is highly recommended. So yes, there is things are in form of PowerPoint for a significant part of this content delivery. However, I'm going to throw something in that is not part of the posted lecture notes, because this here, all the PowerPoint lecture notes are going to be posted. And when I throw something in, because we're going to, maybe there is going to be a question and I'm going to address that, and maybe I'm going to get some idea on how to explain certain concept one way or the other. So I would encourage you to take your notes. Plus, you're going to have this recorded video, so maybe at least you can record the time or the minute approximately when something was talked about. Right? All right, communications, check FOL. You know that email will be the main method. We communicate through email, and that's just a general statement here. I'm usually pretty fast with responding to emails. Sometimes some people were laughing because they would send me an email at 2 o'clock in the morning, and 2:05 they get the response. Sometimes, right? But usually within 24 hours, you get my response here. Here is I didn't put your instructor. I changed that to your teacher because I'm actually I'm a full-fledged teacher from Western University, Ontario College of Teachers here, and I'm also a Fanshawe graduate. Electronics was my main thing, but then I took so many courses that over the years that I will have to fill out the page. All right, so over 30 years of experience in telecommunications industry, mostly data and signal infrastructure. Yes, I did some pro audio, security surveillance, electronic bench repair. That was interesting. Field installation and service, custom device. Sometimes a client would request a certain device to be designed and manufactured. And yes, I was doing that as well. Not that much, but sometimes it would be, it had to be done. So custom devices, design, fabrication, installation, and commissioning. What's commissioning? Commissioning is that when you get your hands dirty doing all kinds of installation and crawling in the ceiling, crawling under the floor, pulling wires, installing things, and making things really nice, then you're going to put a shirt and tie and present that system to the people that have purchased it, because sometimes if there's a more complex system, after installing it, you have to show the client how it works and what it does. Okay, this is I'm going on my 8th year teaching at Fanshawe College, so I'm quite comfy within the environment right now. All right, so that's about me. Enough about me. Let's talk about you. So, how do you like me talking? Okay, yeah. That would be a non-narcissistic at all. All right, so today's objectives, we're going to get a brief course introduction, and okay, we'll discuss how the course works. Quick review of the introductory lab, but we already did that lab. So we're going to talk about the next lab on Monday in our in-person class. Announcements, check the announcements. Content browser. I set up that there's teachers items and student items. So when you go into the content part of the FOL, you're going to see the posted lecture notes and all the labs to be printed. I'm going to ask you to print the labs. And I'm going to say it again. I'm going to ask you to print the labs. So come with the labs already printed. Got it? That's your responsibility. I could have continued with printing the labs for you, but it's just like holding you by your hand. And here's, whoever did the philosophy statement, and it goes like this: if you want to destroy somebody's life, make sure they have nothing to worry about. And then they're going to be, that person is going to grow into a complete useless person because they will not know how to do anything. So let's have some responsibility on you. Get into some good habits. Tablet is good. Yeah. Tablet is okay, as long as I can sign it, and as long as you can use that thing, as long as you are comfortable with that. Email is the general communication. Please check regularly for updates. The attendance will be taken in all the lectures. Attendance is not really mandatory, to be honest. However, it isn't, and it is, because if you don't show up to classes, you're not going to pass the course. So, yes, you don't have to be here, but, then if you're planning not to be here, then they just why bother taking the course? You paid money for it, right? So might as well use that. Milk it all you can. All right, but from what I can see, this is a pretty good group. Attendance is pretty good anyway, so I don't think I have to say that. Telecommunications fun. Okay, telecommunications. What am I gonna say here? Control L for laser. All right, look at that. Fundamentals of telecommunications are studied and practiced in lab exercises. Well, I teach two different communications courses. The other one is what I call the modern telecommunications, and it's basically data infrastructure, and it's more hands-on. This is a different type of telecommunications, or actually this is the original telecommunications concept. So, well, here's a statement, all right? Complete telecommunication system is studied data in primary components, and so, I'm not going to read that. You can read this thing here if you wish. Topics include principles of modulation, noise bandwidth, and channel capacity. So there are some of the concepts that we're going to cover. Basic theory of transmission lines, fiber optics, and wireless technologies in relation to potential mediums. What kind of mediums do we have to deal with? For the most part, medium is it's not someone who's going to, you can go and visit, give them $50 and they're going to talk to your dead relatives. But in this case, medium is a carrier, physical carrier of a signal. So for the most part, we distinguish three: copper, fiber, and air. Copper is the electrical signals, antennas or radio guides, which would be the coaxial cables. Excuse me. Fiber would be fiber optics. They can carry signal pretty good. And air, well, all the radio stations are using air to deliver the radio morning signals, and all this hee ha 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 in the morning when you're driving to work through the antenna, which transmits the electromagnetic waves through the air, and it gets into your car radio through the antenna in your car, and it gets to your ears. Oh wow, we almost covered the whole chain link, or the whole chain of the transmission train of the telecommunication model. All right, labs. If you're unable to attend, always, well, send me an email. All right. If you miss a lab, it won't be possible to attend another section. We're going to cross those bridges as we come to them. So just be vigilant. Be on. Well, you know what? I get a pretty good feeling about you guys yesterday. So from the first time I saw you, I don't think we're going to have any of those issues. Lab work must be completed and successfully demonstrated during Missed labs or late labs will result in reduction of the grades. So these are just the rules that we have to go by. Labs will be due and handed. So you notice that I'm stamping the due dates on that. So unless otherwise specified, then well, actually, what I'm going to do is I am going to set up the dates on the submission boxes, right, as well, and you're probably going to see that as well. But due dates are important. All right, the labs are being submitted electronically, and we need a clean PDF with instructor approval will be submitted. So when you fill up those by hand, make sure that you have nice and clear writing. And here is the idea of doing the labs. So I'm trying to kill the bird with two stones, right? Or what is it? Two birds with one stone? Yeah, I think that's better. Okay, so first is that, well, we need to evaluate you on the evaluation is part of the curriculum delivery. So we have to have that, and it has to be in some sort of organized way. But just evaluating for the purpose of just evaluating, so I could give you some marks. Yeah, it has some purpose, but not quite 100%. What's the other side of the coin that I'm trying to give you? It's the idea of deliverables. Deliverables is the documentation that is submitted upon completion of whatever project you're doing. You're going to do that at work, whether you're going to work at service, in service, that means installation and service and whatever, consultations, design or whatnot. You will be dealing with the deliverables either in a way that you will prepare them and submit them, or you will receive them by from other people submitting them. The idea of clear communication through the deliverables is, well, nice and clear communication. So the person just have to put yourself in the other person's shoes. Somebody's going to receive the documentation that you're going to give them. Do they have enough information on what was done, what materials were used, how many of what, and how is it that they can bill the client for it? Do they have clear picture of that? And usually the offices or companies who decide to hire you, they will set up the deliverables in certain way. So some of the rules might vary. The idea is to pay attention to what is being asked of you and just do it as asked. Then nobody gets hurt. There's no problems. Then there's clear communication going on. Everybody's happy. You're happy. You keep receiving your paycheck. Your boss is happy because he's getting his paycheck much bigger than yours, but you still should be happy, and so on. So that's the idea. I'm not going to. Okay, that's as much as I'm going to tell you. The idea is that you develop good habits when it comes to this. And yes, we are going to talk about transistors, op-amps, and circuits and whatnot. Yes, you absolutely have to know that. But here's the thing. That's the thing to say these days. Here's the thing. You go to work and you know how to do this, that, and the other thing, but there's that new concept of filling up the paperwork in the form of deliverables, and you are completely lost. Or you go to work and you get the idea of deliverables and go, oh, I heard that concept. I know what it is. So all you have to do is just kind of see some of the details of how but you know the basic concept of deliverables, right? Pre-lab work. Well, we're going to do some pre-lab. All the labs are going to have some pre-labs, and I'm just finishing up the lab 2, so I'll probably release this either tonight or tomorrow sometime. But I'm going to try to get. Well, you know what? Don't do the pre-lab until we see each other on. I think it's Monday that we have the next lecture, right? So we're going to talk about a little bit on that. About the second lab. So I'll kind of walk you into that and help you with the concept of the pre-lab work. And the pre-lab is going to be checked within the first 5 minutes of the lab. Here is the military kind of discipline here. Whoa. All right. Example, lab 3 is scheduled for, okay. You can read that example. Late submissions will be subject to penalty. Students absent for 2 more labs will not be awarded with passing grades. So we only have so many labs. I think it's 7. You don't do 2 labs. Well, you're going to have a hard time passing this course. Actually, you're going to fail this course. Again, by what I can see so far, I don't think we're going to have issues. You look like you seem to be a pretty good group, but all right. All right, so here is our schedule here. Here's the weeks. Here are the dates. So week 1, September 2 to September 6, which is Monday to Friday. 2nd is Monday, 6th is Friday, and so on. So Monday to Friday, Monday to Friday. Contact hours. Usually we're going to have 5 contact hours, which means hours spent in class. We have 3 hours of lecture and 2 hours lab time, so that comes down to 5. Some of that here, for example, we had 4 contact hours this week because we lost the Labor Day Monday, right? And here is the, I just have to fit that in, so holiday days, holiday day. Right? Here's that Monday. There's another holiday that is going to affect us, which is the Monday after this so-called reading week, or attempt to have the reading week. Every September semester, it works that way. There's a partial week that is taken off, and it's worked into the so that's this. Usually, that's what happens since the fall term. And usually what happens, depending on the academic calendar, how the holidays work out with each other and whatnot. Every year is different, but usually this is what happened in the September term, and usually in the winter term we get the whole week, but that can change depending on the academic calendar. All right, so that's basically how you read that here. Altogether, we are going to end up with 66 contact hours. 1 exam here, orientation day, Here is the lab, sort of like a roadmap. Here's the roadmap. Here's your window to your success. Week 1, here's the equipment introduction. This is what we just have done. Then week 2, we're going to only have that shifting amplifier lab, which is coming soon. Just 1 week. That should be relatively simple lab. Then you can see lab 3, 2 weeks, lab 4, 2 weeks, everything's 2 weeks. And then there's an open lab. Don't count on an open lab. Don't plan that you haven't done something, you're going to do it in open lab. Well, what if you get the flu or some sort of a something, and then you can't, well, keep that option open, but don't count on it that you will actually be able to do it, because something will happen. It could be a snow day, whatever, right? Well, it's December, right? So now I'm going to be quite flexible that if you haven't, you work with me, I work with you, let's have a good relationship. If for some reason you're struggling with some lab and you need extra time, see here, we're going to have enough time to do whatever we need to do. And if you are falling behind with some of that, you can work. Yeah, okay, so let's say week 8, you have to work on lab 5. But if you still are struggling with some of the lab 4, yeah, you can spend a few minutes or whatnot, because you're going to have, the other things. So just have that in mind. Here is the roadmap to success when it comes to that. What page is that? It's the page that comes right after that page. Okay, and before that page. Lab preparation is critical to success. Always bring your lab kits, your PPE, tools, lab print, and if required, pre-lab work. Not being prepared will result in reduction of the grade. There will be consequences for not being prepared. And this is school, so you lose marks. At work, you lose jobs. So it is your responsibility to get, it is your responsibility to get a sign-off for the pre-lab. Here's another thing. It kind of relates to your future at work. It is your responsibility to know your paperwork. If you do a service call somewhere, then you need to get a signature here, initial here, signature here, initial here, and a date here from whatever the client, the manager of a huge corporation or whatever it is, or a owner of a small business. The person who has called you for service, it's not their responsibility to know your paperwork. So it's your responsibility to get all the dots crossed and T's I'd in your paperwork. And I'm not going to be reminding you. But then again, from what I could see, I don't think we're going to have an issue. I'm looking at the chat here. It looks like I assume it would be due today before a second session. Yeah, Daniel, you're talking about the due dates. Yeah, so we did the lab on Wednesday. It is due 1 minute before midnight, Tuesday night, the next the Tuesday after Wednesday. All right, please check machine. Okay, be organized with it, because you don't want to lose stupid minutes on looking for cables and that. Yes, I was able to give you some good. Get your own cables, get your own probes, and for the oscilloscopes, use probes. Don't use the BNC connectors with the alligator clips. Excuse me. Use the oscilloscope probe. Now, if somebody is missing something, we have a little bit of a, but that little cabinet that we have, the purpose of that is not to give you out what you need. It is your responsibility to have what you need. Check the battery on your DMMs. Well, this is from last year because, as we noticed, we do have the new multimeters in our rack. So, you know what? Your choice. You can use your own DMM, or you can use the DMM in the equipment rack. You have the options. Just bring your own leads. And please, please, please do not put the alligator clips into the power supply banana female connectors. Alligator clips do damage those connectors from inside, and they have to be replaced. And because it's a school and this equipment is heavily used by many, many people, then if everybody's putting that in, using alligator clips in those banana jacks, then Perry wouldn't have time to do anything else. He would just replacing those. So, all right. Prior to the lab, you should identify the components needed. Okay. Well, I'm going to say this. Build your circuit before you come to class. Show up with the circuit already. Now, I wouldn't have anything against if you went to that open lab, which is close to the next door to the soldering lab there in B building. Do the lab and just show me the results. Show me how it works. Demonstrate. I might ask you a few questions. That's fine too, if you can do that. But at least try to assemble the circuit ahead of time, because the worst possible thing is that the class time starts and you only have so much time to do this lab. Add the time for troubleshooting and whatever else, and maybe fixing some issues. Then you're going to maybe run out of time and get frustrated with some of that stuff, and that's not the proper thing to learn. Yes, I know you have other subjects. I have no control over that. I'm just making a suggestion that if you want to spend the time more efficient in class, assemble a neat circuit. Neatness is the key to everything. Assemble the neat circuit ahead of time. Okay. B1020 open lab. Yeah, B1020 is the open lab room beside the soldering lab. Will the lab documents show how they should be built? You're going to get a schematic, and those are pretty straightforward. So you're going to have to assemble that in a breadboard in some sort of a neat way, and when we get to the labs, when I see that I could correct some of the way that you're doing, you're in school, that's why you're learning, then I'll perhaps make some suggestions of how to make things a little bit more efficient and simpler and easier to perform the work. All right, grading, lab grading, visual integrity important, 20%. If you do smidges on the, if it's greased up with some butter stains or whatever, lose marks. Reading or writing has to be readable. If you're receiving the deliverables from other people and you have to decipher what they were trying to say, you're going to get frustrated. So if there is some sort of work that needs to be done or more work that needs to be done, which means more paper coming from that person that you're going to hire for, you're going to choose the person that give you clean documentation. So I'll leave that idea with you, right? Depending on which side of the fence you are, and when it comes to the doing the work. Are you in the office receiving the deliverables? Are you in the office preparing them? Get into good habits. Lab prep 17.5%, exactly, not 0.6. Okay. On-time submission, that's worth 25%. However, if the lab, there's a rule that we have in effect. If the lab submission takes longer than 2 weeks, if you're 2 weeks late, then you get 0 on the lab, but you still have to submit that lab in order to pass the course. Lab performance 30%, and workplace hygiene. Leave your space nice and clean. If excuse me, if you find that your station has not been cleaned by the person before you, then let me know. Actually, you got 2 options. You just clean it up and get it over with and move on, and just put a watchdog on it, see if it's happening, if it's just a one-time thing or is it happening regularly. Or you can let me know and I'll let the other professor know that some of the stuff is being left messed up. All right. Okay, lab quizzes. Lab quizzes will be based on the lab content. So I'll be those quizzes are going to be online. Couple questions here and there. This work will be assigned with due dates. Yeah, okay. Instructions to complete the work will be on FOS folders. Yeah, okay. So pretty straightforward. It's an online quiz format. Questions. Lab quizzes, the online quiz format located under the evaluations tab, but typically is going to have 2 hours to do some of that, some of those quizzes, which is way more than is needed. So for a couple questions, having 2 hours to do that, it's just like having forever to do that. Attempts, usually I have 2 attempts, but the last attempt goes on record not the best of 2. So the questions are going to be chosen automatically out of a larger question bank, and every time you open up the test, you're going to get different questions. So if you have 2 attempts, you get 2 different sets of questions from the same barrel or from the same question bank. So the reason why I do that 2 attempts is that sometimes you get kicked out of the internet or you lose the connection or something like that. So when that happens, don't log in right away, because chances are that whatever is happening is still happening. So try to resolve a connection or find yourself another place, different place maybe, to connect with your laptop or computer and do the quiz. So that's why I give 2. But again, the last attempt goes on record not the best of 2, even though you have 2 attempts. Questions, I just said that. Randomly question which each attempt. Yeah, I said that. You process the, okay. So usually with my quizzes, I have that you can only see one question at a time and no backseas. So you can't go back to revisit that question. You answer that question and move on, right, to the next question. It's an online quiz. Come on. I have to give you some kind of a challenge, right? There's my thing here. Course evaluation. Here is the weight distribution of the marks. Test 1 is worth 25% of the whole course. 2 and 3, there are so altogether 75% of the whole course are the tests. Labs are worth 20% of the course, but they have to be done. And lab quizzes are worth 5% altogether. If you add that, it's going to come to 100%. Will the lab documents show how? Okay, I already answered that question. It's going to be, we're going to take one case at a time. And now you'll get all the explanations here. Tests will be based on the lecture notes, lecture slides, discussions in class, students' lecture notes, reference to text. Pretty much all that is thrown at you might be evaluated. Yeah? It is highly recommended that you take notes in class. That's the second time you see that statement here. Yeah? Test preparation should include your review from pretty much anything that we give you should be evaluated. Evaluate the ball. Right? You're responsible for keeping up to date on assignments. So yeah, you do have some responsibility. Safety. While in the lab room, safety glasses have to be always worn. I mean, pretty much that's it. Okay. You have to wear your safety glasses. Arrive before the lab starts. At the beginning of each lab, there will be a typically safety briefing or whatnot. So at some labs, we might have to lock the door after a certain time. Is it going to be 5 minutes? Is it going to be 10 minutes? Doesn't matter. It makes no difference because you're going to show up before the lab starts, right? There you go. Bags and backpacks should be on the floor. Calculator, pens, and might be on the. Basically, this talks about keeping your workspace clean. And as I mentioned that before, you keep your workspace clean, it will be noticed. If you have a mess on your desktop or in your workspace, it will be noticed. And future decisions about you or with you involved might be made based on that. Not officially, but please ask the instructor if you have any questions about at any point while you are working. Yeah, okay, that's pretty much given. That's why you are here. That's why I'm here. The first consideration always is the lab safety. Okay. It has to be said, it has to be understood, and it has to be followed. Always turn off the power to the circuit when making changes. Well, pretty much given. Avoid contact with any live conductors on your breadboard. Had to be said. Troubleshooting circuits. You will encounter circuits that are not working. Here's some of the helpful tips. I already gave you one helpful tip, right? Or couple helpful tips during the lab yesterday. One of the lab's objectives is to continue to develop skills. So, if the circuit is not working, you're going to have to do some detective work yourself first, before you call me. And then, if you're still stuck, but then I'm going to ask you, what have you tried? I might ask you questions. Well, maybe not now, because we have the meters, but there was a question that I would ask a lot previous years. Your circuit doesn't work. You called me. Why is your meter still in the bag? right? Right? That kind of stuff. Eh? All right. One of the lab's objectives is to continue to develop skills. As I said, remember that philosophy statement: if you want to destroy somebody's life, make them, not worry about anything. That's kind of by the same trend. I gotta give you a chance to sweat over things a little bit, and maybe get a little tiny bit frustrated. Welcome to the territory. Yes, sometimes you're going to end up troubleshooting certain equipment, or you're going to have some problems or challenges that are going to really, really frustrate the daylights out of you. It's part of the job. Not always. Usually things are, quite nice and smooth, but once in a while you will get that one that gives you that problem. So the more skills you develop, troubleshooting skills you develop here, the better off you will be when you go to face the real world, so to speak. Systematic approach can shorten the time spent troubleshooting. This can help. Are the supply voltages correct? So this is part of the check the obvious thing, right? Measure at the power supply and at the board level. Again, this is the part of check the obvious. There is certain voltage on one side of the wire, and is it the same voltage at the other side of the same wire of that wire? Could that wire be broken inside, and it's just that break could be hidden by the insulation or the jacketing? Yes, it could be. Have I seen that? Yes, many times. Jumpers can fail, breadboards can have poor connections. So this is all part of check the obvious. Yes, it should be there. Does it work? It should. I know it should, but does it? Check and double check. A lot of the problems can be actually require just that. Checking the obvious. Oh, something is not there. It should be there. It looks like it's there, but it's not. So, breadboards can have poor connections, and ground can often be missing. All right. So that's part of the check. Have all the instructions been followed? Sometimes you have to retrace your steps. It's a good idea to start at the input. Okay, so start at the input and work towards the output. Depends on what kind of circuit it is. There are two basic concepts. One is signal tracing, and the other one is signal injection. So depending on which way you want to start, if you're troubleshooting maybe some kind of audio mixer or audio amplifier, you can start at the end and look for the signal where you're going to begin to see the signal in the circuit. So you go backwards, or you can inject the signal and go and follow the signal and see where it stops. You can work either way, whichever way suits you, and is better method for that. So there are some names, signal injection or signal tracing, or signal injection and tracing, right? And you can go forward or you can go backwards with this, following the signals and see at which stage the signal disappears, and then you're going to have to address the problem or solve. Just present with a solution. Come up with a solution. Have all the instructions. Okay, it's a good idea to with that, but other methods might be applied depending on the circumstances. Okay, resistors and capacitor values. Check the values and measure if needed. Even though with measuring, some of those pico diodes, or otherwise called signal diodes, and these are those diodes that are they look like small glass type of almost like a quarter watt resistor, or maybe even smaller, and orange glass with the brown other end. These are those called pico diodes. Quite often when I was working a long time ago at repairing musical instruments, keyboards, mixing boards, amplifiers, and whatnot, whenever I saw some of those diodes around op amps and around other circuitry in that troubled area, I would just replace them. I'll just take them out and replace them because those diodes are funny. Sometimes even if they check okay with the meter, still something is wrong with them. Right? So sometimes it just comes with the experience to know but When you use the resistor, double check the value. See, maybe there's something wrong with the resistor. Yes, it looks like it's okay. Verify whatever you can. In our lab, these measurements must be done with the power off. This is what we teach in most of our courses. If you want to check the resistance of a resistor, you have to take the resistor out of circuit, and one of the ways is to lift one leg. If you lift one leg of the resistor, that whole resistor is out of circuit. Then you can measure the resistance. However, as you go along, if you know the circuit that you're troubleshooting, sometimes you don't have to take that resistor out of the circuit to see if something is good or not, because you'll be expecting certain values at certain places. However, the power, when measuring resistance, one thing, power has to be shut down. That's a given. But also, when I say that, sometimes you don't have to start with the proper thing. Remove the component out of the circuit. It's a good rule to follow. Later on, if you are absolutely sure what you're looking for and you can see, then you can. But take this. If you want to check the resistance value, take it out of circuit, because then you can be sure that you're only measuring the resistance value of that resistor. If you don't take it out of the circuit, you're measuring the value of that resistor and all the resistance in parallel to it that is connected. All right. Is the circuit built correctly? I know this might be kind of obvious thing, but it's a good thing to review. Are there missing or wrong connections? It's very easy to make a wrong connection on the breadboard. Take special care with the pinout on the devices. How many times did I screw something up? Did I mess something up? Because I was just too sure of myself. Oh yeah, I know that pinout. I remember the pinout of that component or whatever. I don't need to check with the manual or the data sheets. And it turns out that it was just like a different revision of the, and I just connected the boom, right? So this is one of those things. Check things, make sure, verify things. Don't be too sure of yourself, as I was many times. But then again, I'll tell you, somebody told me to not do that, and I did. Chances are that I'm telling you to not do that, and you'll be doing it. But you've been told. Test leads can fail. Okay, test leads can fail, as well as the test equipment. Yes, we had some meter in the electrical lab a couple years ago. And we measured the voltage in the receptacle. It shows 60 volts. How can that be? There should be 120 volts. And there's half, So I go to the technologist, Mr. Deporter, and I go, yeah, what's going on? Well, we grab another meter. No, it shows 120 volts. The meter was pushed. How many times over I'm not even going to tell you how many years I've been using test equipment, multimeter and things like that. I've never had that happen. I've never seen a multimeter fail. Well, there's the first time for everything. Test your leads. Leads can fail. We can replace them as needed. Configuration of the scope or generator might be an issue. Yeah, we already had some of that yesterday. These are the new scopes, and I'm still figuring them out. All right? So try the power cycling and resetting if needed. All right, we've gone through this page here. Text a book. Here's the electronic version of the textbook. Here's the link. Is there a link here? If you don't have access to the textbook, let me know. But do we have the textbook? This is Electronic Communications Systems Approach. There's an online version of that. let me know. I might ask you to read some of the text from that textbook, but it's a really good textbook to have. Yes, we will refer to that. Lab kit. I just took some pictures of the bookstore. Here's the entrance of the bookstore. If you go over here, that's where our kids are right here, and they look like this. Yes, see that? Some of them are in the bag, and some of them are in the cardboard, sort of like boxes. They are the same thing. It's just different packaging. And that's what the kit looks like. All right. Lab rules. Lab kit must be brought to class. DMM safety glasses, If you're missing equipment, you might not be able to complete the lab. Spare DMM's cables that will not be kept in the lab. Okay. All right, here's a statement, okay. Desk must be, okay, clean up your space. Phones should always be on silent, Get into the habit. Well, I'm not sure if you've seen something like that or not, but I've been around many companies on many job sites. There is something that I think there's a new disease or new syndrome, and it's an allergy. People who are seasoned workers are allergic to seeing other people with their cell phones at the job place. After a while, you will be allergic to that site as well. Besides the safety aspect, because what happens when people walk through the intersection, crossing the street, even on the at the appropriate place, just look around you. Things are in motion. Get it? Okay. So that's the safety. And then there's that signs of the tombstones. Here lies the one who had the right of way. I'm pretty sure you heard that one. But also, it's quite annoying. Forget that you have a cell phone at work, at least for the first couple of years. And then you will just not be using, because you'll be allergic to seeing other people using cell phones when they should be working. Aside from the safety aspect, you actually can lose. I have seen people lose their jobs because they just couldn't stay away from the damn phone. Bye-bye. If you encounter defective equipment, please inform the instructor. Equipment should be treated with care. Repeat. Where's my laser? All right. Respect others, and okay. Please do not have conversations when okay. Here is my rule of the jungle. One monkey is talking and other monkeys are listening. So I'm the talking monkey. Okay. No further drinks in the lab. It's just, well, first, it's rude to talk when somebody else is talking. And, well, you're not getting the benefit of being in class. But if you're talking, you're disturbing other people who would like to listen to whatever is being said. If you have to pick up the phone, or if there is something that really can't wait, that you have to talk to your friend about, just take it outside. Go outside, have a 5-minute conversation, come back in. Just don't slam the doors, because it's annoying too. All right, how can I do well in class? Attend all your scheduled classes. Well, take your own notes. Lecture slides will be online. This will be online. Do all the assignments, questions to check your understanding. That's the purpose of the evaluation, to see if you actually understand. It's not for me to have excuse to give you a mark one way or the other, because at the end of not the day, but at the end of all the days, you will leave the school for one last time, and you'll face the world. You gotta have the knowledge. There's not going to be a person your friend sitting next to you, so you can copy their results or something like that. You will be there. Okay. Well, I feel like I don't have to say that. Read all the instructions. Read the instructions and do the troubleshooting properly. Right? Be on time for lectures and labs. Complete all preparation for the lab. Pay attention to detail during lab exercises to avoid personal injury. Still can happen. That's why we do have safety glasses are not the answer to all your life problems. However, safety glasses are mandatory, and they do work. And over the years that I have worked in the industry, I can tell you that they do work. They worked on me. And I have friends who were not as lucky as me. They didn't want to wear the safety glasses because there's nobody watching over them. Nobody's going to tell me that, so I can do whatever I want. Bang, right? And I got one of my friends has problem with his eyes right now for the rest of his life. Ask questions and if needed. All right, cool. All right, so that's the end of this part, and we're going to have to go to the second part. So look at that, it just took 1 full hour. Do you guys want to take like a 5-minute or 10-minute break, and so we can continue? Going to get a sip of coffee, use the facilities. What I'm going to do. Okay, nobody's responding. Are you all guys like are you all sleeping by now? Not yet. All right. Okay. I know. Yeah, break sounds good. Let's get 10 minutes. All right. So it's all right. On my phone, I can see it's well, almost 11. So let's meet again here 10 after 11, and we're going to continue with that. 10-minute break should be fine. Right. So on our phones, ladies and gentlemen, let's synchronize the watches. I'll be right back after 10 minutes. Here is a typical microphone preamp. Oops, yeah. That's how the multi-sim works. Here's a typical SM58 microphone. Here's the pinout of the microphone. And you can see that if anybody worked with any of the audio, pro audio or stage amplification or stage setup and whatnot, you will notice that the cables they have 3 prongs. Why do they have 3 prongs? All right. The reason why they have 3 prongs is, one is that so-called virtual ground. And here is one part of the signal. And here is the other part of the signal, which is a mirror image of the signal. So it's 180 degrees out of phase. Same signal. What does that give us? Well, here's the wonderful device. This is just one of the uses of the op-amp. I'm just showing you that just to get your interest in that thing. The operational amplifier reacts to difference of the potentials, or the attempted difference of the potentials at those 2 inputs. If those 2 inputs are at the same potential, you will get no reaction on the output. If there is ever so slight difference, then the amplifier, the op-amp, is going to notice that and is going to try to do something with it. How is it that this is used with that pretty practical application here as a microphone or any kind of audio signal that is so-called balanced? There is the idea of a balanced signal and unbalanced signal. Let me get my board here. There's my board. Just gonna put that aside for now. Here's the idea of a unbalanced signal. Here's the one terminal, here's the other terminal, and usually the other terminal is grounded. And here is the cable. Here is the cable. And it is transmitting, the cable is a medium to transfer the signal. And it is terminated at the other end, and it goes somewhere to some sort of a, see, this symbol here is a symbol for an amplifier. And the signal goes into the amplifier, not necessarily operational amplifier. And this thing is grounded, and at some point, some of the input, the other is grounded. What do we have? We have a signal going through the hot terminal. And it gets, depending on how long the wire is, it will get attenuated. Sometimes it gets attenuated in an insignificant way. Sometimes it's going to get attenuated in a significant way. And attenuating means, well, making it smaller, degrading it, reducing. Right? So it is going to go right here, depending on how long the cable. Some of the cables, as far as audio or otherwise, they could be 2 feet long, or they could be 200 feet long. If the signal is strong enough, the signal that gets to the other end of the cable is going to be relatively clean. Whatever noise, because you get the idea of induction. There's all kinds of interference in the air. Would it be from the radio stations? Would it be from the equipment that is around us? Could it be that a Volkswagen drives by or whatnot, right? It is going to introduce electromagnetic waves that the cable will pick up. And the longer the cable is, the more noise is going to accumulate and is going to affect the signal. So if the noise is just really kind of insignificant here, it's going to carry on and it's going to be part of the signal, but at the other end, the signal is going to be clean enough to be considered usable. All right, what if the signal is not that strong? Because, for example, if you have equipment that is active, example, keyboard is an active equipment because you need to plug it in and it uses power, so it's active. It has active electronics inside. It is able to produce a signal of a power that whatever we want to. So usually it will be like 1 volt peak to peak. Now, microphones, if it's a dynamic microphone, like this one here, it's a passive device, which means we don't plug it into power. It's whatever the movement of the membrane creates the disturbances around the coil and magnetic field and whatnot. It creates electrical signal, but it's relatively weak comparing to active devices. So it would be in the range of maybe 1 millivolt. Well, if you have 1 millivolt, and if the signal, if the noise gets there, if the noise, let's say this is a magnification of it, if the noise is there, comparable to the signal, it is going to arrive there. Right. And it's going to be part of the signal, and it could, if the signal to noise ratio is strong enough, then you're going to have a signal that is not that usable. Notice one thing. The noise is always in phase with itself. So if there's a positive part, of the waveform, here's the noise. If there's a negative part of, again, there's the noise. The noise is with itself in phase. We can do something with that. So this is an unbalanced system, unbalanced signal. Now, let's get to something that would be called balanced. Get a pen here. What do we have? 3 terminals instead of 2. We got 1, 2, 3. Third one could be the ground. Let's do it like this. And we're going to carry 2 other veins. Yeah. We could carry the ground as well. Now, if we get a differentiated signal or balanced, we're going to make that, and it's very easy to make. All you have to do is get a transformer. Tap it in the middle, and you get 3. It will give you this here and here. So if the signal is like this here, and if we have out of phase signal, then if the operational amplifier, which is also considered as differential amplifier because it senses the difference in voltage between these 2 inputs, then if there is a signal and it's handed to the operational amplifier in such way that with 2 terminals and they're 180 degrees out of phase, then the signal is going to be recognized and processed by the amplifier. Now let's see what happens if we introduce noise to the cable, because the cable could be susceptible to noise. Let's say a Volkswagen drives by. It is going to create a noise, but look how it's going to create a noise. Here's a spark or spike, and here is a spike. Look, these 2 are in phase. So whatever is delivered to those 2 inputs that are in phase, it is going to be ignored. So the signal could be quite noisy, but at the output you're going to get nice and clean signal without that noise, because the noise is in phase. So if the whole thing rises, it rises both same amount at both inputs, so it doesn't create a difference. The noise doesn't create a difference of potentials, so the noise will be ignored. You're going to have a clean signal. With the balanced signal, you can transmit weak signals way further than with the balanced signal when it comes to, for example, audio, but it could be other signals. All right, now let's see how it looks like, because I just have that thing connected right here. Here is the power supply connected, just plus 15 volts, minus 15 volts, just the way we connected the power supply in our lab yesterday. So the power is supplied to the op amp. There's some circuitry involved, and it does have some negative feedback, and things are dressed up with resistors. We're not going to analyze this thing right now at this moment. Later on, we will. But look how the signal is handed in to the inputs. the signal, I just, instead of having a transformer, I just simulated those with two different signal generators that are of the same voltage. So this was 0.5 millivolts peak, 0.5 millivolts peak. So there's 1 millivolt peak to peak here, 1 millivolt, but these are out of phase. See that here? Here's a positive, here's a negative side of this, and they are completely out of phase. Delivered to these two. And let's see, I connected the scope. Let's see how things look like. I'm going to turn on my scope here and start the simulation right here. Boom. Oh, look. I'm going to try to pause it so we get sort of, can get it better. There we go. That's enough. Look, here's one of the inputs, and here's the channel 1, which is yellow. Here is negative, which is the channel 2, which is the blue. Here's the output right here. And the output is in phase with the pin 2, which is the blue one, which is going to the non-inverting input. All right, so far so good. So where's the noise? All right, let me show you how it works with the noise. I'm going to add 2 more signal generators and I'm going to simulate noise, but those 2 are going to be in phase with each other. So let me with noise. There we go. See, I've added 2 more signal generators. These 2, this is the main signal right here. So that gives us the waveforms out of phase. And these here are in phase with each other. So the noise see those 2 signals right now, instead of being nice and clean, they are noisy. But the noise is in phase. In both terminals, the noise is in phase with each other. What do we have on the output? We have still nice and clean signal. Let's see what happens. Let's go crazy here. And let's increase the noise. We have 1 millivolt peak to peak noise. Let's increase the noise. Let's have 2 millivolts peak to peak. But we have to make sure that both of them have that, because that's the idea of the noise. It's affecting both wires in the same way. So I'm just going to have to compensate for that here. Now we have a bigger noise. Let's see. See, still we have a bigger noise here. The signal is still nice and beautiful and clean. So that's the idea of the differential amplifier. See, I told you, I promised you, you're going to learn something today, not just the logistics of the course, which is important. All right. So here is the just the beginning of that, just to get you interested in some of that stuff. Now let's see how far we can go with the slides. Is that the... No, that's the one that we just had. Module 1. And let me just start that here. Good. All right. Telecommunications. The circuit blocks in telecommunications vary widely, and it's referring to this second slide right here. Circuit blocks in telecommunications. Well, you're going to have some sort of something that creates a signal. You're going to have some sort of processing stage. Excuse me. You're going to have some sort of amplification stage, transmission lines, and the transmission lines, if you remember, for the most part, we distinguish three: copper, fiber, and the air. So the signal has to be carried on some medium. Can you use water? Some of the spies, international spies would use water to transmit some of the signals, blah, 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 right? But for the most part, we're using copper, which is electrical signals, fiber optics, which is light signals, and air, electromagnetic waves. And those three are being used heavily when it comes to telecommunications. So you're going to have, it's not drawn here, but you could see here it shows output transducer. Quite often you're going to also have some sort of an input transducer. What is a transducer? It's a very mysteriously sounding type of a word. A transducer is a device that converts one form of energy into another. Like, for example, the microphone that we just saw. A microphone converts the longitudinal vibrational waves, which are physical vibrations of the air, mechanical vibrations of the air, turns into electrical signals. It's a transducer. On the other side, you would have a loudspeaker, or popularly called a speaker, which would convert electrical signals into air vibrations. It converts one form of energy onto another. What could be another example of a transducer? Thermometer. It converts the it converts the temperature of the surroundings onto a readout. If it's an electronic thermometer, it would convert the temperature into electromagnetics or electrical signals, which could be processed and then displayed. So, and there could be other kinds of other transducers. A transducer converts or transfers or turns one form of energy onto another. So it's not drawn here, right? So what else do we have here? Frequency modulation and high frequency carrier. All right. What is the idea of a carrier? Because we're going to be dealing with some modulation or modulations. Here's the intelligence, and here is the carrier. All right. Some of that, it's also not drawn, so it's transmitting medium. Over here, it could be also connected to a transducer right at this, where's my laser? Right at this stage, the signal would have to be passed through another transducer. And in this case, it could be an antenna, which would convert electrical signals into electromagnetic waves that would disperse and propagate through the air. And there will be another transducer here, which would be another antenna, which would convert the electromagnetic waves into electrical signals. And all that has to be amplified, has to be processed, amplified again if necessary, and shot through the output transducer, which usually is something that is understood or readable by us humans, usually. So if there's a microphone, now things could be digital or could be analog. If it is digital, usually the processing within, transmission and whatnot, processing and transmitting the signal, receiving and processing again, that could be done digitally in a digital way. However, it still, in this case, would pick up something that's analog, and it converts at the end of the day. It's the colloquialism of today's times. So at the end of the day, it is still going to have to convert into some sort of analog form, because we humans are not able to read digital signals with our senses. For our senses would be what? Eyesight, hearing, smell. I'm not sure if you can transmit smells, but you can always try. So it could be all analog circuitry all the way from beginning to the end, or it could be analog converted to digital and converted back to analog so we could use it, so you could sense it. Major blocks, amplifiers, oscillators. Okay, so here's the idea of the carrier. A carrier would be, in this case, a high frequency signal that is transmitted all the way, so the tuner right here can be tuned in to that carrier. And then when the carrier is established, it's just like, when you have that, the old 2 cans and a string communication, right? You get the string and 2 cans, and you can talk to 1 can and the other person can. That string is the carrier. It carries the signal. In electromagnetic waves, it's a high frequency signal that is established by the transmitter, and the tuner, whatever the tuner is, it has to tune into that carrier. So establish a quiet connection. So when tuner locks onto the carrier of whatever the transmitter is transmitting, the carrier of whatever the station, radio station, TV station, or whatnot, and if there is no intelligence signal tied with the carrier, you're just going to have a complete silence. So sometimes we know that you have tuned onto the carrier is that you hear the noise and quiet. That means you locked onto the carrier. And then if you add low frequency intelligence information, because this could be megahertz here. Megahertz is way beyond human hearing, and that could be propagated. Now that carrier could be distorted, modulated, disrupt, interrupted, bothered, otherwise modulated by the intelligence, which would be human voice, could be music, could be whatever else, tones. Then when the carrier is modulated by that, then the processing circuitry here is going to receive that carrier modulated with the intelligence, and internally is going to strip off the carrier, and is going to keep the intelligence, amplify it, and send it through the speaker. There you go. Simple system block diagram, sort of telecommunications or communication. All right. What else do we have here? Now, since we've gone over that, it's going to be easier to read this one here. The circuit blocks of telecommunications vary widely because the blocks could be arranged in a different way. Like, for example, there is no input transducer listed here, but it would be part of this system here. All right. Now, but there are some common ways of, it's a good starting point. These circuits might be passive, resistor, capacitor, or active, transistor, operational amplifier, etc. What's the difference between active and passive circuits? Active circuit needs power. An active circuit needs to be plugged in and needs some power to work. A passive circuit does not need any power. Like, for example, a microphone. It could be, well, there could be some active microphones. Yes, they are. But the dynamic microphones are passive. Resistors. Resistor is a passive device. It doesn't need power to operate. It can carry power, but it's just a device by itself. Capacitor is a component. Transistor, well, on the other, that's a different side, the story, because it needs to be powered to operate. Excuse me. Together, these circuits are used to build transmitters and receivers, which are the basic building blocks for any communication system. These circuits might be analog, or we just talked about that. Modern smartphone, for example, uses a combination of analog and digital circuitry. Early cell phones, 1970s, they looked like a brick. It cost a lot of money. They used only analog circuits. In fact, the analog carriers or analog systems were still in operation maybe 7 years ago or something like that. Then all the phone systems, the cell phones, switched to digital. So some of the older cell phones are pretty much useless in what's being used right now. So it's all the transmissions are digital. However, a modern smartphone uses combination of analog and digital circuitry, because that little earpiece that produces the sound waves that you can hear in your ear, it has to be analog, right? Because if you was just transmitting digital signal, you would just hear that modem noise, something like that, right? And you would not be able to understand what the other person is saying. All right, another concept. Linear and nonlinear circuits. Both linear and nonlinear circuits are used in telecommunication circuits. It's important to understand the difference. Okay, let's see here. Linear circuits. In a linear circuits, the relationship between the current and the voltage could be established as a straight line. Linear line. Non-linear, no straight line. Okay. However, some of the non-linear devices can also utilize part of the characteristics that from here to here it acts as linear device. So let's set up the device, or let's bias it in a certain way, let's configure it a certain way that we're going to use just that part of the, some conditions have to be met. So transistors are, this is a diode characteristic, current and voltage. See, it behaves nonlinear here. Starts behaving a little bit linear, sort of linear here, and then non-linear again. And same here. Well, that's all nonlinear at the back. The reverse bias. Important, I think, is that in linear circuit, the relationship between current and voltage can be established as a straight line. One increases the other. They are proportional. The proportions, the relationship between current and voltage could be funny in nonlinear circuits. It's different. It changes depending on different things. It could be from certain voltage, it behaves a certain way. If you exceed some voltage, it behaves completely different. Temperature changes, it might be behaving certain, different and whatnot. There's also phase linearity, but we're going to come back to that slide here later on. I feel like I need to give you a little bit more on that one. All right. Now, amplifiers. I would strongly recommend that you would review at least the Class A amplifier or a BJT transistor. So here is your little bit of an unofficial homework. So review the operation of Class A amplifier. And that's where I'm going to look at. That's the operation of the Class A amplifier. And there's the operational amplifiers. Now, there are some rules, but you probably remember those, but I'm going to review them again. Operational amplifier characteristics. We will be dealing with those a lot. I'm giving you some building blocks on what we can use. Op amps. It has an infinite open loop gain. It has a high input impedance, so it could sense, low signals. And it has a low output impedance. Low output impedance, so it could be very efficient, spitting things out. Op amp rules. This is when, because sometimes you're going to see a little bit of more complex circuit, and when you're dealing with a complex circuit, you're going to find a way. Let's find a way. How do I bite into that circuit to actually, where do I find a starting point? These help. These rules help. So, rule number 1. You probably know that, but I'm going to have to say that anyways, because that's just the kind of guy I am. There is no current flowing in or out of those inputs. There is no current flowing there. Rule number 1. Rule number 2. The potential difference, or otherwise the voltage between the two inputs, is supposed to be 0. It is always, the amplifier is going to do whatever it can to keep those two at the same potential. And it's the output's job to make sure that it happens, because this is just a bare op amp, but there's going to be some circuitry connecting the output to the input, and that's called a feedback circuitry, that the output is going to try to make, if it's connected to that or if it's connected to that. Well, the condition is with negative feedback. That's the condition. So the rules apply. That the output is going to try to make those two equal as far as voltage. So no current flowing in and out of those. It's a really good thing to remember. And that this here is going to be equal. So if this was 3 volts, that's going to be 3 volts. If you know that this is 5 volts, that's also going to be 5 volts. It's how you begin to solve the circuit. And we're going to get some examples of that. Now, here's the third condition here, more than like a rule, but it could be treated as a rule. If the calculated output is higher than the power supply voltage, then the rule 2 doesn't apply. They might be different potentials. Last thing I'm going to show you here is the simplest, okay, where's my, there it is. Simplest demo of the op-amp. Is that one there turned off? Everything is turned off. Simplest of the op-amp. Now, forget the rules right now because there is no negative feedback, so we don't go by those rules. But remember when I said this amplifier reacts to the difference between those two inputs and it's going to give you an output. So right off the bat, what's going to happen when I simulate this? Here I have a power supply plus 15, minus 15, just like we set up in our lab. I'm going to turn on the voltmeter display. And what do we have here? We have 1 volt applied to this, and independently we have 1 volt applied to this the input. So here's non-inverting input, inverting input. Let's simulate the circuit. Should be 0, right? But it's not. Because there's ever slight, so this multi-sim is trying to simulate the reality. There's always going to be certain slight amount because the voltage gain, the open loop gain. Open loop means there is no feedback between the output and the inputs. If it's an open loop, then the gain is ideally infinite. Is it? Well, it is. It's striving to be infinite. But where's the limits? Well, the power supply is the limits. So if one of the inputs is a little bit higher, then the output is going to turn that way. What do I mean by that? With the open loop, there's no feedback, no negative feedback. If this non-inverting input is going to be slightly higher than that, then the output is going to go, because infinite gain, boom, all the way as far as it can, and it's going to reach the upper limit. Or if that one is slightly higher, then it's going to go the other way. Let's check it. So now, it's just took us all the way up to the positive rail. All the way up? No, because there's still some circuitry that are affecting that, so that thing goes almost to the end. Now, there are certain operational amplifiers on the market that they actually will take it all the way up to the power supply. So it's just reading the specs, right? Let's increase that voltage ever so slightly and see what happens to the output. I'm going to stop the simulation, and I'm going to make it 1.05 or 0.05. Let's see what happens. Is that going to be enough? 1.005 volts. Slightly different, slightly bigger. Okay. So this here is slightly higher voltage than that. So it should take all the way down the output. Let's see. Oh, look at that. It just took it all the way. See, just very, very small difference. Now, let's take it the other way. Let's make this 1.006. So that one here, we're going to make it slightly 1.006. All right. Is it going to take it? Because infinite gain, right? Let's do it. Oh, it is 14 now. Almost 15. It took it all the way up. All right. So I think we're getting close to the hour here, and I realized I'm just holding you a little bit longer than I should. Did we do all that I wanted to do today? Maybe not, but we're going to carry on next lesson, which is going to be, I think it's Monday. And we're going to wrap up the first module then, and we'll take care of some of the pre-work for the labs. All right, but I think we have covered enough for you to chew on. For some of you, maybe it was a good review. For some of you, maybe it was an even gooder review. But I'm satisfied with what I gave you today, and I will see you when I see you next time. If you have any questions, send me an email, because I realize that you have to probably go to another class or something like that. All right, we're good. We're good. Thank you. Have a good one, guys, and have a good Friday.